Hello everybody. Today I am Doug. Today we are going to discuss about the hyperplane. What are hyperplane? The first question which arises is what is hyperplane? Okay. Basically, hyperplane is used where we have some classification problem. For example, if I want to classify that the particular image is a cat or a dog, then there we need certain criteria after which we need to say that it's a cat. For example, if it has a triangular ears, then we would say that's a cat, and if it has long ears, then we would say it's a dog. Or similarly, we need a certain criteria to tell us that the email is a spam or a ham. So there are various in a classification problem we need certain criteria, and to create a certain criteria we need a hyperplane. So in other terms, if I put it, so hyperplane is basically a plane separating the two classes. For example, if I have a class C1 and class C2, if I check it like this, so if I have, let me increase the, okay, so for example, if I have two classes and they are I have a data, and the data have two features, x1 and x2, right? And actually x1 and x2 are defining the two classes. So there are one class that is a square, and the characteristic feature of the square class is that it has x1 and x2 are comparatively small for all the squares. And when we have a circle, the second class, then the x1 and x2 is comparatively large. So when I plot them on the graph of x1 and x2, I would be plotting the circles on the later half of this graph. And when I plot the square, they are closer to the origin, and when I plot the circle, they are far away from the origin. When I so if I need to draw a certain line like this, then I could say this line is everything above this line is a circle, everything below this line is a square. So this line basically dividing the two classes, the class 1 and the class 2. This line is known as a hyperplane. This line is known as a hyperplane. Okay. So this currently we have only two features, but in practical, in real life, there won't be two features, there will be many features. So the hyperplane in this when we have a two-dimensional graph, the hyperplane come out to be a single dimensional line. When we have a multiple features, for example like this, then the x1, x2 and x3, then the hyperplane would come out something to be a plane. So in this case, so the hyperplane would come out to be some plane here, which is dividing the two classes available here. So the dimensions of the hyperplane are always the number dimensions of the features, minus 1 is the dimension of the hyperplane. So this brings us to the next question. What is the equation of the hyperplane? Okay, so what is the equation of the hyperplane? Let me zoom it a little. Right. Okay, so what is the equation of the hyperplane? So hyperplane is basically when I have a single dimension hyperplane, then that is a line. Then when I am having a line, then the equation would be y equal to mx plus c, the simple equation of a line. So this could be in the terms of features, this could be written as, or if I reshuffle the LHS or RHS, it would come out to be like this. Some plus W2 some weight for the y, some weight for the x plus c equal to 0. This could be the equation of the line, a line which is also a 1D hyperplane. If I further change it to the in a feature format, then I could write it as w1 x1, where I am saying y is also some features which we have used. We have drawn it like this, x1 and x2, as you will remember. So we have used y as x1 and x as x2. So w2 x2 plus c equal to 0. So this come out to be the equation of a hyperplane. If we have, as we discussed, when we have a multiple features and the dimension of the hyperplane 2 increases, and it's the dimension of the feature -1, then we have the we will keep on adding the weights and the features in this equation. So if I would write it for the just give me a minute. So if I would write it for the plane, then it would be something like this, a two-dimensional plane. It would be w1 x1 plus w2 x2 plus w3 x3, and for this c, let us take it as w0, which is equal to 0. So if I generalize this equation, it would come out to be as w0 plus summation of I equal to 1 to n, if I have n features, wi xi. This would be the equation of the hyperplane in general terms. Okay. Then now it brings us again to the next question: how to classify data. Now we know what is the hyperplane, we know what is the equation of the hyperplane. Now the next question which arises is that how can we use the hyperplane to find out which data point corresponds to which class. For example, if I would say that means I could see that on the left ones are the class 1, on the right one of the hyperplane are the class 0, then how would I be able to determine it mathematically? So we will see it now. Let's change the color of the pen. Okay. So to determine mathematically how to classify, so let's again draw a 2D. For example, I have two features x1 and x2 available with me, and this is the hyperplane we just saw, and we saw that the square ones are basically below the hyperplane and the circle ones are above the hyperplane. So this circle is corresponding to some value of x1 and x2. So if I would say it is x1 bar and x2 bar, similarly this square is corresponding to some value of x1 and x2. So if I would say x1, it corresponds to x1 bar and x1 double bar and x2 double bar. Okay, so if I put it in the equation of the hyperplane, which came out to be like this: w1 x1 plus w2 x2 plus w0 equal to 0. This was the equation of the hyperplane which we got. So if I put the value of x1 here and x2 in this, then this hyperplane will result in the value greater than 0. This will result in the value greater than 0. If I put this x1 and this x2 in this equation, it will result me a value which is less than 0. So mathematically, if I keep on putting these data points in the hyperplane equation, then for these data points I am getting negative value, and for all these data points which are ahead of the hyperplane, I am getting the positive value. So for the data points which are behind the hyperplane, I am getting the negative value. For the data points which are ahead of the hyperplane, I am getting the positive value. Okay, so if I get any data point now, random data point which exists here, if I put it in the equation of the hyperplane, I would get I will get the positive value, and then I can say that it belongs to the class of circles. If I have any random data point which is available here, and I put it in the equation of the hyperplane, and the value I got is negative, I can say that it belongs to the class of square. So this way hyperplane help us to distinguish between the two available classes. One is a circle and other is a square class. So it always putting any data point in the equation of the hyperplane will result in the positive value if the point belongs to the class ahead of the hyperplane. If it belongs to the class behind the hyperplane, then it will result in the negative value. Okay, having said that, it brings us to our next question: how to choose the best hyperplane. Okay, so let's take us again to the example of the squares and circle. I have square available here which are near to the origins, the square class, and I have circles which are available away from the origin. Now it can have this hyperplane which help us distinguishing these two classes. We have this hyperplane, we have this hyperplane as well. So actually we have infinite number of hyperplanes available. So how to choose the best available hyperplane? So to choose the best available hyperplane, there is a concept known as maximum margin hyperplane. So to choose the best hyperplane, we have to find out the hyperplane which give us the maximum margin between the two classes. For example, if I consider okay, so if I have considered hyperplane 1, hyperplane 2 and hyperplane 3, then hyperplane, if you will see, hyperplane 2 is closer to this point in the class C2 and closer to the point in class C1. Similarly, hyperplane 3 is much closer to the class of C2 and much closer to the class in C1. But hyperplane 1 is very much far ahead from both of the classes. So the margin provided by hyperplane 2 is maximum. So we have to choose a hyperplane which provide the maximum margin between the two classes, which between which we want to distinguish. So so if I would say, so now we know what is the best criteria to choose the hyperplane. The best criteria to choose the hyperplane is to find the hyperplane providing the maximum margin. So the next question come out to be how to find the maximum margin. The maximum margin would be maximum distance between the closest point, right? So before this, we should understand how to find the we should be able to find the distance from the hyperplane. After we would be able to find the distance from the hyperplane, we know that we have to just calculate the maximum margin, and the hyperplane providing the maximum margin from between the two between the nearest data points of the two classes will be considered as a valid hyperplane. So let's move on and find this. Let's see how to find the distance from the hyperplane. Okay. So okay. So the equation for finding the okay. So the equation for finding the distance between a point and a line. Distance between a point and a line is is this. This is a standard equation for finding the distance distance between a point and a line. So here we would simply replace these x value with the point value. For example, if you want to find the distance between x1 and y1, then we will simply replace these x1 and y1 and calculate the distance between the point and the line. So when we when we put it into our equation, let me rub it. Okay, so when we put it into our equation, we have an equation. So like this, it would come out to be w0 plus w1 x1 plus w2 x2 w1 square plus w2 square. This is the distance between the points. Okay. So if I transform this equation to something like this, can I write this equation? This is the magnitude. Basically, I am calculating the magnitude of the numerator. So can I write it like this? W0 W1 comma W2 dot 1 x1 x2. Can I write this equation like this? Yeah, sure. So basically, because the dot product is the element wise multiplication, so w1 will go with the 1, w0 will go with the 1, w1 will go with x1, w2 will go with x2. So actually we have element wise multiplication, it will result in the same equation. So there, as we know, there can be more than 2 features, so there can be more than 3 weights which are available here. So in the generalized term, we can write this equation as vector w, taking this as vector w and taking this as the vector x dot of vector x by root of w1 square plus w2 square. Okay. This would be our distance. So I can write distance as follows. So distance is basically this formula which is shown here. Also, we can make this formula. We can use it. We can say that this particular distance is actually a scaled distance. This is actually a scaling part. So we are just dividing I can say that we are dividing a particular value by a constant. So I can say that distance is nothing but a scaled part of this w in the scalar multiplication of w vector and the x vector. Or if we try to ignore the scaled part, we can simply say that the distance is more or less proportional to these two components. Okay, so this also just try to remember this equation. So let me move back to this equation, so we can move to this part. Okay, so if you will see that this is the equation of the hyperplane, so we can simply say here that this equation, yeah, this equation, we can write this equation simply as equation simply as the scalar product of w vector and x vector, the dot product of the w vector and this x vector. So actually this is the equation of hyperplane as well. So the equation of hyperplane can be represented as the dot product of the w vector and the x vector. W is the weights and x is the features equal to 0. This can also be represented as the equation of, not exactly x vector, I would say y vector, where y is this vector 1, x1, x2 and further features. So there is a 1 which is extra in y other than the x. So I could say it is the dot product of y vector and w vector. Okay. So if I move it, so the equation of hyperplane is also w dot y equal to 0. Similarly, the equation distance of this will also be y, because this is basically a y vector, not x vector. This is a y vector, not x vector. So it would be distance is directly proportional to the equation of the hyperplane, basically w dot y. So now we know how to able to find the distance from the hyperplane. Now we will move to our next part, how to choose the maximum distance hyperplane. So having seen the equation of the hyperplane, so it brings us to the next question, choosing the maximum distance choosing the maximum distance hyperplane. Okay, so we know that the equation of the hyperplane, let me write the equation of the hyperplane is weighted vector, dot product of weighted vector and the y vector is equal to 0. This is the equation of the hyperplane which is available here. Okay, so anything below it belong to the class 1, anything above it belong to the class 2. If I put the data point of the class 1 in this equation of the hyperplane, it will result me as w dot y less than 0. If I put this is for the class 1, if I put for class 2, it will result me w dot y greater than 0. If I label the class 1 in my dataset as -1 and I label the class 2 in my dataset as +1, and I multiply the label, if I would say L as -1 and L as +1, if I multiply the label for these two equations, then it would come as label into dot product of, obviously the dot product of 2 will return me a scalar quantity. It will come as w dot y for the class 1 is always less than 0, and multiplying it with the -1, because the label of the class 1 is negative, it will lead to the inversion of sign of greater than 0. And similarly, w dot y for the class 2 is always greater than 0, so multiplying it with the positive label will return me greater than 0 again. So if I multiply label again, it will return me greater than 0. So in the both cases, I am getting label into the equation of the I won't say equation, label into the w dot y will result me into the positive quantity. Okay, As I also, if I can say that if I have a hyperplane, it should satisfy this equation. For every hyperplane to exist, it should satisfy this equation. But this equation, as we have seen in the previously, that this equation can be satisfied by the infinite number of hyperplanes. So to choose the hyperplane which is best suited, we need to calculate the maximum distance, maximum distance from the basically we have to calculate the distance between the data point which is nearest to the hyperplane and the hyperplane from the both of the classes. So there might be a data point which is available here, and the distance come out to be m1, and this distance come out to be m2, and I found that m2 is less than m1. So I chose the distance m2 as my m equal to m2 for the hyperplane I. So if I have infinite hyperplane available, then for all those hyperplane I will calculate the m value. The m value is the closest distance available between the hyperplane and the nearest data point of from any from both of the class. So the minimum distance between the hyperplane and the data point of any of the class is termed as m. So for every hyperplane we will calculate the m, and we will try to maximize this m, that is the margin we call as margin. So we try to maximize the margin. So we were using this as a classifier, L dot W dot Y greater than 0. Now we will change this classifier as should be greater than m, and any hyperplane which will satisfy this condition where m is the maximum, what we can say, it is the maximum of these margins which we have received, which we have taken out. So we will put this maximum margin here, so I can write it as m max, and any hyperplane which satisfy this equation shall be taken as the final hyperplane. So let me summarize this session for you. So we first saw what is a hyperplane and what is the use of a hyperplane, how it is used to differentiate between the two classes, what is the equation of a hyperplane. We found out the generalized equation of the hyperplane. We looked into how can we classify the points using the hyperplane. We looked into how to choose the best hyperplane, how to find the distance of a point from the hyperplane, because to choose the best hyperplane we need to get the maximum margin. And if we have found the maximum margin for the infinite hyperplanes which are available, then how to what classifier equation should we create to so that the hyperplane should satisfy that equation. So that's all from my side today. Thank you, have a good day, and do subscribe and like the video. If you like the video, do subscribe my channel, and if you have any doubt, please raise it in the comment.